All right, thank you very much, Mr. Papamaster, for that wonderful talk. So our third speaker in the engineering session, and I just have to point out, we had heard from the Chief of AI from the Air Force, maybe the best Air Force in the world, the CTO of one of the most important chip companies in the world, and now we're about to hear from the director of, I think, the most important space center in the world, only in Texas and only at TAMEST. Really is a reminder of how great of an organization this is. So it's a great pleasure to introduce, okay, you're going to break right through. Okay, very good. It's a great pleasure to introduce Vanessa Wyche. She's the director of NASA's Lyndon B. Johnson Space Center. She was elected to the National Academy of Engineering in 2023 and became a TAMEST member. So it's really a great pleasure to have you here today, Ms. Wyche. Please join me in welcoming her.
Good morning. Thank you very much for having me here today. As was mentioned, I'm a new member, and so I'm very excited. This is my very first occasion. I'm going to take just a few minutes to talk about what we're doing at NASA's Johnson Space Center, and I believe that the presentations before are a good setup for how we're having space applications of AI and machine learning. My talk is going to be very cross-discipline because it's going to cover all of the academies. It's going to cover medicine, engineering, science, and technology. So one second, got to find it. Okay. Here we go. So right now, today at NASA's Johnson Space Center, our concentration is human spaceflight. Many of you that are from Texas, you may know that during the shuttle era, we had the space shuttle, we built the space station, and we were planning future missions to the moon and to Mars. Well, right now today, that is finally coming into fruition. At NASA's Johnson Space Center, we are busier now than we have ever been in our history. We have responsibility for the International Space Station. It is a research and technology platform that is near our Earth. We call that low Earth orbit. And we are responsible for spacecraft technologies for and operations and management for the Commercial Crew Program. Additionally, we are responsible for commercializing low Earth orbit. And so there are platforms that are being designed today for us to continue to have presence in low Earth orbit when the space station is retired. We're working on all of the elements that we need for our first initial element and implementation of the Artemis program using the Orion spacecraft. We are working with many companies across not only just here in the US, but around the world. And I'm going to talk about all of these in detail. But in the very center is you see an astronaut, and he is in a spacesuit. And the program that this supports is the Human Space Flight Research Program. And because the human is at the center of what we do, and I'm going to talk about how we're planning and working to do human robotic exploration of the moon and to Mars. But one of the things that we're also responsible for at Johnson Space Center is commercial lunar payload services. Those are robotic missions that will go to the moon that are being done by our commercial industry. You may have heard about a company called Astrobotics. They tried to do a robotic mission to the moon. It was not successful. They had a propulsion system error. However, they're in the queue to try again. And very soon, we have a company right here in Texas called Intuitive Machines. Their launch window opens on February 12th, and they will be trying to have the first commercial lander on the moon. We work with all of these vendors to share our technology, our expertise, testing, et cetera, as they go about their ventures. But this enables us to have NASA and our government workforce to also then focus on the assets that we need to develop that have technology barriers that we're working on. I'm going to talk about all these in detail, but I kind of wanted to lay out for you a landscape of all the activities, and these are just the major programs that are going on right now today at NASA's Johnson Space Center. The International Space Station, we have this crew, this is Expedition 70. The crew members that got to the space station, many of them, 4 of them went up on a SpaceX Dragon, and then 3 went up on a Russian Soyuz. We are still cooperating with our Russian counterparts on the International Space Station, as well as those from JAXA, Europe, Canada. And these are the core international partners. The International Space Station has had our astronauts living aboard for over 23 years continuously. And we will continue those operations until about 2030. That's currently when we have been authorized to operate through, and then at that point, we're looking at transitioning. The International Space Station allows us to do research for most of the increments. These folks are operating about 300 experiments at a time on board the International Space Station. But these technology demonstrations, et cetera, are being done you can get to the International Space Station in about 4 to 6 hours. We have flight controllers that are on the ground that help them with these operations. One of the things that we'll need to do as we go further, deeper into space, for example, to Mars, which is 200 million miles away and takes months to get there, is everything will need to have some component of autonomy, and many things will need to be completely autonomous. And we do those studies right now on the space station. So I think I'm going to be able to get this video to play. Hold on.
The greatest single thing that we've learned on the space station is to grow and eat our food.
NASA has learned a tremendous amount from the International Space Station, build and construction, not only from a technological perspective, but from a human side as well. The integration of medicine and behavioral health and performance that helps us to set the stage for subsequent lunar missions and long-duration exploration missions.
NASA has learned so much from the space station program and the ISS. We've learned about how to live and operate in space. We've learned how to do research and microgravity technology development.
And with that video, I wanted to be able to show to you the laboratory that the International Space Station is today. And, you know, many people have seen the astronauts on board. You may see them just flying in space, and you're wondering, what are they doing all day? They are extremely busy. They do research for about 8 hours every day. And we're also now flying what you guys may have heard of as our private astronaut missions. At the bottom of the screen there, in the darker uniforms, those are astronauts from a company called Axiom Space, which is also in Texas. And they have been, this is their 3rd private astronaut mission. These crew members had about a 2-week stay, a little bit extended because they should have landed over the weekend, but with weather in Florida, actually we just waved off again today. So I'll find out in about an hour when they'll be coming back. But they're on board. They're doing research as well. They are doing everything from life sciences to material studies. They are also doing quite a bit of PAO activities. We have astronauts. They have astronauts from several countries, from Turkey, Italy, and I think Spain. Right now, they flew up on a SpaceX Dragon. We are working with our industry partner at Boeing. Boeing is developing a spacecraft called Starliner, and that spacecraft is scheduled to have its first crewed flight tests. That will be done with NASA astronauts as test pilots. Right now, we're shooting for April for that launch. This transportation capability will be needed to continue low Earth orbit transportation to follow-on space stations. And these are companies right now that are designing and developing space stations for that future. Axiom Space, as I mentioned, is here in Texas. The other companies, Nanoracks, Lockheed, and Voyager, have a agreement together. They're all around the U.S. We do have a presence of them in the Clear Lake area. And then Blue Origin and Sierra Space. Sierra Space actually is also building a transportation capability. They will have these right now. We're working for 2028 for those to come online so that we can have some time for an overlap so that we can make sure that they're operating properly and we will not lose our presence in space during that time period. While that is happening, we're transitioning and also working on the Artemis program. So that's our lunar program. And we have tested, we did last year, a uncrewed flight test of the Space Launch System, which is the rocket that launched the Orion spacecraft. And the Orion spacecraft, our prime contractor is Lockheed Martin, but it is managed out of NASA's Johnson Space Center. And right now we're building towards our first crewed flight test with our astronauts. This will be the first time that our astronauts have gone beyond low Earth orbit since 1972. These are the brave soldiers.
I'm a mission specialist.
I'm Jeremy Hansen. I'm a mission specialist.
I'm Victor Glover. I'm the pilot.
I'm Reed Wiseman. I'm the commander for the Artemis 2 mission to the moon.
To the moon.
To the moon.
To the moon.
So they will be going to the moon on the Orion spacecraft. These are some of the major elements of Artemis that are being designed and developed by our team at the Johnson Space Center. Our intent will be that we will do this crewed flight test, and then the next test would be for us to land on the surface of the moon. There are two companies right now that are designing human landing systems. One of them is SpaceX. They're actually building that and testing it in South Texas, in Boca Chica. And then the other is Blue Origin. With that landing system, we will have the capability to go to the surface. We are also designing a very small platform that will be in lunar orbit called Gateway. And that platform will be the way that the Orion spacecraft, our intent would be to go to the Gateway. The landing system will be there. Our astronauts would transfer and go to the lunar surface. As we build up capability on our first missions, we'll probably have the Orion to dock with the human landing system, and later we will add the Gateway. I already mentioned to you the commercial lunar payload services. And so what that will allow is for us to have robots and robotic capability on the surface, as well as humans, and working together. We will need surface elements. Right now, the element in the middle is probably the first to come online. It's a lunar terrain vehicle, and we have commercial companies that are bidding right now to be selected. The lunar terrain vehicle, which is going to be different than the moon buggy for Apollo, will be able to operate autonomously. Our astronauts in early phases of Artemis will go and we will have what we call tended stays. So we'll go to the surface, do operations, and then return before then later having capability for a moon base. the lunar terrain vehicle will be able to do science operations while we are not there with our humans. Additionally, the pressurized rover is an element right now that our Japanese counterparts are designing with their commercial companies, Mitsubishi and Toyota. That will allow us to have the ability to go further when we do our exploration. And to do all of these things on the surface, of course, we need spacesuits. The spacesuit that we use today on the International Space Station when we do spacewalks was designed back in the 80s. It was designed for shuttle. We've made upgrades to the suit, but the technology itself is based on that. We're working with two companies, Axiom Space again, and Collins Space, to have our future spacesuits for our Artemis program. On the commercial lunar payload services, at Johnson, we are also designing a rover called Viper, and it is scheduled to launch on one of the astrobotics missions. And that rover, again, will be doing autonomous operations on the surface, going and finding and maybe doing things that our humans would not be able to do. But as was mentioned by Colonel Hamilton, you know, the human still will need to be the decider. So while the data is being looked at and maybe looking and saying, okay, this is where we want to go next, then we will make sure by having a human in the loop to be the decider of, yes, this is the critical science that we want to actually explore. And so this autonomous decision-making will also allow us to do all of our surface-to-surface elements while humans are not there, and when the humans are there, allowing us to make sure that we have a good layout and understanding of where we're going to place our elements, and then for those to be able to talk and communicate with each other. There are many different things that we will have to learn about living on surfaces, foreign surfaces, and because once we do that, then that will allow us to translate those same capabilities and we go to Mars. So I'm going to run out of time, so I'm going to talk really fast. We have, you know, need for, if you think about infrastructure, we're going to need to have surface power. We're going to need to have looking at using the capabilities that are there on in the regolith itself. So we have a activity called in situ resource utilization, where we're looking at taking the lunar regolith and being able to get water from it. How do we get that to sustain our presence on the moon, but also at some point maybe to even make fuel using that. All of those studies and activities are underway right now today, and as we look at what is our big landscape, what is our forward path. So this is actually, and it's maybe a little bit small for those in the back of the room, so I'll try to describe it for you. But along the bottom, what it's identifying is what's our sustainable path for from the moon to Mars. And there's surface elements as well as in-space elements. And the initial capabilities will start, we will have 2 people going to the surface. They will operate this lunar terrain vehicle that I described to you to be able to support operations, as well as robotic capabilities that will help with identifying what are the places, where do we want to go, how are we going to explore, and helping us to analyze the data. Then going forward further to the right, adding the capability with a foundation surface habitat. So that would allow the astronauts to be able to go and have a several-day stay, building for having 4 people on the surface of the moon, with having the lunar pressurized rover to allow further translations on the surface. Along the very top, the in-space capabilities, I mentioned to you the gateway. And the gateway was actually chosen, the actual location, because this is the place where we'll be able to do testing of our transport systems that we would need to go to Mars. And so we would do a dress rehearsal for Mars, and then eventually be able to do our Mars missions. We'll go to Mars, and Mars is 200 million miles away. I think I mentioned that. And so right now, it's looking like we would be able to do that. If we have new breakthroughs in our propulsion capabilities, that would allow us shorter times. But an average mission would take about 3 years. So that's why it's so very important for us to learn how to live and work on another planet where we're closer to home before we try to make that big giant step. However, in the meantime, we can actually do these analogs right here on Earth. We have a Mars analog right now at the Johnson Space Center called Chapea. And we have 4 people that are currently in a habitat that was actually 3D printed by a company called Icon that is out of Beaumont, Texas. But these 4 people have been inside of a habitat that's inside of a building at the Johnson Space Center for 32 weeks now. They'll be there for a year. Our intent is we're simulating Mars surface states. And so they will be in this habitat until a little bit later in the summer. What we're studying is the behavior and nutritional impacts of being confined. And also we are able to simulate the time delays that you have with transmitting from Earth to Mars. That being could be 6 minutes, it could be a 40-minute delay. So they are doing experiments, they're growing food within the habitat, and it's amazing to me, if you see the food habitat at the bottom, that they've been able to do that in 32 weeks. These are the first of 3 crews that we currently have planned for this simulation. To do this takes many people on the ground. And so I did want to highlight the fact that, in order for us to do these missions, we have to have capabilities right here on Earth. Our Mission Control Center has right now 24-hour ops for the International Space Station. When we go to the moon, we know that we need to have more autonomy. And then once we go to Mars, so the way that we're doing our missions is going to change. We train our astronauts at the Johnson Space Center. We have 1G training, we have 0G training in a huge swimming pool called the Neutral Buoyancy Laboratory. We also do high performance test training. We have a small aircraft fleet out at Ellington Field. The video earlier, our T-38s are what we train our astronauts in. You saw one in Colonel Hamilton's video. We are also working with food, because we have to send food with our astronauts. Well, we also work with our industry partners and academia on providing all of these capabilities. And we have a test facility in New Mexico called White Sands Test Facility. We do propulsion and materials testing there. We have about 3,000 government employees and about another 8,000 contractor employees at the Johnson Space Center. And then we have remote employees in Russia and all around the world. We're a highly technical workforce. About 75% of our workforce is science and engineering background. Then we have lawyers, we have accountants, many other people that are required in order for us to do these missions. Within the state of Texas, annually we have about $2.5 billion of projects that are within the state, and then outside of the state, another $4 billion. We are working with all of our industry partners to help to commercialize and enable all of the things that we're doing in space. We're very appreciative of the relationships that we have with our other government partners, the Space Force, which now used to be Air Force, For example, in Florida, it's very instrumental still in all of our launch capabilities, our landing, return capabilities. We all work those with the Department of Defense, as well as our academic partners to be able to do the research when we have science research as well as the food technology, et cetera. One of the things that I'm super excited about is within the state of Texas, we are looking and working together on what's the vision. And from a Johnson Space Center standpoint, you know, we want to see Texas be in the hub and continue to be the leader of human spaceflight. And so we've been working across the state with all of our partners on that bright vision. I'm super excited about the new Space Commission that the state of Texas is standing up and the Space Institute at Texas A&M University. Those are the things that are going to allow us to be able to continue to propel going forward. I do have an ask, that is we do need to have a workforce, we need talent. This is just our fall interns, and they are there all together. We have postdoc, we have you know, the, college students as well, and want you to please share that we're continuing to have our internship program, but also lots of opportunities. And also very proud of the fact that Johnson Space Center continues to be a place where people want to come to work. And so we have been voted for 2 years in a row, the #1 place to work in Texas. So you should feel that it is great for you to send your students and or your friends and children to do internships. And so this is my last chart, just ways to connect. We do have a large presence on social media. We try to make sure that others know what we're doing because what we are doing is for the benefit of all humanity. So that's my last chart.
All right, wonderful. Thank you so much for the inspiring speech. All right, we have time for a few questions. Please go ahead.
Thank you so much for the presentation. Ruzbe Jafari from MIT and Texas A&M. NASA has been leading the work on digital twin for many decades. Do you have any plans to create sort of a document that walk us through what NASA has been experiencing since 60s and where it is now today as a sort of a lesson learned for the rest of disciplines?
Oh, yes, thank you. So actually, that's a good idea to do a document. I will say we are working, and I don't know if Heather Wilson is here, but we have been working on a digital engineering collaboration center, as well as we're working to have all of the data that we have, making it available digitally to share with others. So I don't know that our plans for to do a document, but we, definitely have that right now to share out with others what we're doing with all our digital data. Thank you for asking that. And then to access all of the data that's readily available, you can go to our website. Not all of our data, of course, is going to be there, but right now we have been working on digital twins. For example, for Orion, we have some students that have been helping to build a digital twin for the Orion spacecraft.
Thanks, Ruzbe. Please go ahead.
Hey, Manish Kumar, UT Austin. Thank you, Director Wyche, for that wonderful presentation. I have a small-minded question in the context of space, but maybe important. Who owns the moon, and how do we govern it?
So, you know, within the United States, we have what's called a Space Council, and the Space Council kind of sets policy to say, like, who has responsibilities for different things. So the Space Council includes NASA, but it also includes the Department of Commerce, it includes the State Department, Department of Defense, et cetera. So I would say that within our government, that's the policy setting part of it. But then, of course, there's the, Outer Space Treaty, And we have been working for the Artemis program for civil space. We've been signing agreements with other countries called the Artemis Accords. And right now today, we actually are up to our 35th country that has signed on to those accords to say that we will cooperate peacefully in space. Thank you.
Okay, we have time for one last question, so please go
Oh, I
ahead.
feel so lucky. Thank you. Christine Economides from the University of Houston. I just have to ask it. We're in a session on engineering and AI. Do you know of competing efforts with similar goals that would strictly use robots?
Of competing apps?
Efforts.
Efforts, okay.
So get to the moon, get to Mars. I mean, the value of getting there might be more than just getting people
Oh,
there.
yes, absolutely. So we have, right now today on Mars, rovers. And so the Perseverance rover is collecting samples on the Mars surface. And we plan to get those samples back robotically. At NASA's Johnson Space Center, we're, as I mentioned, this commercial lunar payload services, we are working with, I think there's probably 8 vendors currently that are planning robotic missions to the moon. So they're, not that it's a competition, I would say it a little bit differently, that we see the importance of having humans and machines working together. But our, I'll give you an example. We had a science mission director head who talked about the fact that, yes, he can send robots, but the robots don't have the same scientific mind that a human does. And so, yes, it can go and it can explore. It can pick up what we say, and it can maybe even learn to do things. But for example, we can send them, and they may be able to explore, and they can go about maybe 1 kilometer. But if we had a human, they would be able to go further and go to places that maybe the robot would not be able to go by itself. So that is why we are working to make sure that we enable the human-machine capability together.
Thanks very much. That's helpful.
Okay, thank you.
All right, I know there are more questions, but unfortunately we have to move on. But again, let's thank Ms. Wyche for a wonderful talk. Thank you very much.
Thank you.